All right, so this is what we need to find, right?
Yeah,
Average
I got
interchange.
that part.
So G of 5 then is the area under this curve from 1 to 5.
Like, you don't have to do anything.
Okay.
I just took the area from 0 and
Oh.
not 1.
Do you want to look at the problem? No problem.
So anyways, then for B, I just get confused with the G.
Okay, so instantaneous rate of change means slope, right? So it says find the slope of G. So, like you just told me, the slope of G is G prime. So G prime is equal to F, right? So this is just saying find G prime of 3, which is the same thing as F of 3. So I just want to go to the graph and say, well, at 3, it's equal to 4. All right, so they try to trick you by saying, or explain why it doesn't exist, because if we're looking for the slope of this graph, the slope wouldn't exist here because it's a corner. But we're not looking for the slope. We're just looking for the actual function value of this graph. Okay. Anything else? Make class. Here.
How did yesterday go?
I went well. Both Quinn and Case made it to districts.
I did not go well.
They will have to play each other in the semifinals now.
Will you look at video of this? Oh, I thought they had to play each other.
Yeah, we're done.
No, not so. The semifinals and finals are tomorrow. So
Won't be here tomorrow.
But so
I'll be here in the morning. It's only a half day thing in the afternoon.
but they both like automatically still made it to the district.
Yeah, so the top 4, like once you get down to the semifinals, all 4 of those players make it to districts. We just play for seeding now.
So like they can't keep each other out of the tournament.
Right? Yeah. They,
Oh,
both,
that's not
so
good.
they both made it already. Thanks.
Okay, so I didn't do C either.
Okay. So on C.
Because one time I couldn't do the first 3
All right. So on what open intervals is the graph of G concave up? So concavity, we want to think about second derivative, right? Where is the second
So
derivative?
is it the derivative of X?
The derivative of F. Yeah.
Yeah. Okay, well then yeah.
Okay. So it's just saying where is the slope of this positive? So from -5 to -2 and 0 to 3. Yeah. And then D, critical point, is where the derivative equals 0,
So it's just
where F equals 0, right? So that would be at,
they're still critical.
right. This would still be a critical point, but it would then be neither a min or a max. Right, so we would say at -2 and at 1, and then we could make a sign chart. Right, we could say -2 and 0, and then negative, positive. So at -2, we have neither a min or a max. And then at 0, if I'm changing from decreasing to increasing, that would be a local min. Alright. We okay with that one? Any other questions? Alright, then get out the little packet. We'll do types 5 and 6 today.
So like, what are we doing on Monday?
Nothing structured, just like last minute questions.
Wait, what day is
Just,
our test?
Tuesday.
So like, oh my gosh, so we only have to get Tuesday. Well, it's not gonna be so like, I'm not gonna be here on Friday. I mean, I can show you my book, but like, are you gonna take off points and I'll show you it on Monday? Okay.
You can just show it to me on Monday.
Okay. It's not.
I will give you completion.
Yeah, there's a lot of English stuff where I'm gonna check my grade. I'm gonna have like my have like an F or something.
We've taken up all of class time doing stuff, so I haven't had time to check your stuff in class.
Are you going to be checking it?
Yes, I mean, probably just check everything on Monday. Like when we're doing our last minute questions and review stuff, I'll just.
What's everything? It's just
Are you gonna put in? Are you gonna put in?
I haven't checked the multiple choice stuff from last week either. You gave me yours, but I haven't checked that for.
Like basically like all the reviews.
Yeah, like all the review stuff.
Are you gonna put it on one table?
Yes, I still have those to grade as well.
Okay, as long as you're good.
Yes.
I guess I'll just have time to do it.
Bless you.
Thanks.
Alright, so type 5 is table or Riemann sum problem. Okay, we've looked at a lot of these types of problems fairly recently, and again, not going to read through all of these what you should be able to do type things. Okay, but I do want to kind of point out some of the do's and don'ts down here. So, do remember that we do not know what happens between values in a table. Okay, so for example, if we've got something that goes from 1 to 2 and 3 to 4, right? So this is my x, f of x. So we know that we've got the point 1, 3 on the graph, and we've got the point 2, 4 on the graph, right? I have no idea what happens in between those two coordinate points. I mean, the graph could do something like this, right? We don't know what happens. So we can't assume, right? That's one of the big things that we have to remember when we're looking at a table problem. Another do is make sure that you show your work. For one of the bigger ones is if you're asked to find the average rate of change, which is just slope, okay? A lot of times you can do something like that in your head, right? Especially for something like this. You can find the average rate of change in your head very easily. Make sure that you write down what you're doing. Show your slope calculation, even if it's really simple. And show your work. But you don't have to do the arithmetic. Right? So if you have some long string, especially when we're doing Riemann sums, a long string of numbers being added or subtracted, do not add and subtract. Just leave it as a big string of addition and subtraction. And also, don't leave expressions like r of 3. Right? Make sure you pull out that numerical value. So let's take a look at a couple of examples. So first, in this example, we are given 3 different functions, 3 different ways. We're given g and g prime in a table. We are given a graph of h, and then we are given a function to define f. So, first, part A says find the slope of the line tangent to the graph of f at pi. Hopefully we remember how to find a tangent line. We need 2 things, right? We need the point and the slope. So I need f of pi, and I need f prime of pi. F of pi will get me the point, f prime of pi will get me the slope. So f of pi is just cosine of 2 pi plus e to the sine of pi. So what's cosine of 2 pi? 1. What's sine of pi? Sine of pi would be 0. So what's e to the 0 power? 1. So this would be 1 plus 1, 2. So this tells me that the point pi 2 is on the graph. Then I need the slope. So I guess before we find f prime of pi, we should find f prime of x. So how do I find the derivative of this function? What's the derivative of cosine? Negative sine. So this will be negative sine of 2x times 2, right? Don't forget the chain rule part there. Then what's the derivative of e to the sine of x? sine of x times cosine. So now I just plug pi into this. So f prime of pi, negative sine of 2 pi times 2 plus e to the sine of pi times cosine of pi. So what's sine of 2 pi? Sine of 2 pi is 0, so all of this would just be 0, right? Then sine of pi, we already said, was 0, so this is e to the 0, and cosine of pi is negative 1. So this would be e to the 0 times negative 1. So just negative 1, right? 1 times negative 1 would get me negative 1. So the information we've collected is that we have the point pi 2, and my slope is negative 1. Now I just need to write the equation of my tangent line. So y minus y1 equals m times x minus x1. So that's part A. All we dealt with was F for part A here. Part B then says we're going to define some function k to be h of f of x. Find k prime of pi. So if we've got k is h of f of x, I guess before I worry about any of these functions, what they actually are, how would I take the derivative of this? Chain rule. Yeah, if I've got a function of a function, you did state a rule. So the derivative here, I take the derivative of the outermost layer and times the derivative of the next layer. So h prime of f of x times f prime of x. So now we want to plug in pi. Right? So k prime of pi will be h prime of f of pi times f prime of pi. Well, from part A, we already evaluated f of pi and f prime of pi. Right? We found that f of pi was 2, so this becomes h prime of 2. And we found that f prime of pi was negative 1, so times negative 1. Now, we need to figure out what h prime of 2 is. Right, so I'm given a graph for h, so I just want the slope of this graph at 2. So right here is where x equals 2. What's the slope at that point? Negative 1/3. Right, we're just finding the slope of this line. So this becomes negative 1/3 times negative 1. Technically, we could stop there. Right? Obviously, this is a really simple thing to multiply together, but we could just leave it as negative 1/3 times negative 1. Right? You okay with that one? I guess another thing I should point out is make sure that you separate your calculations. Okay, so if I write down k of x equals this, make sure that you're not just putting another equal sign and then writing a derivative. Right? Though the function is not equal to its derivative. Make sure that you separate those two ideas. So then I can write k prime of x equals this. And then if I'm going to plug in pi, I need a whole other idea. So I'm going to say k prime of pi then is equal to this. Right? Part C then says we're going to take some other function, m, and define it to be g of negative 2x times h of x. And we want to find m prime of 2. So, m of x equals g of negative 2x times h of x. So, I need the derivative. Sharon, how do I take the derivative? There we go. I figured you would get that.
Well, no, because I didn't even look at the problem, so I was trying to write it. Even I didn't know. I was wrong the first time, so.
So if this was your chance to give the same answer, then be right.
Well, after I got.
Anyway. Product rule, take the derivative of the first times the second. So how would I take the derivative of g of negative 2x? G prime of negative 2x
Hey, Sharon.
times 2.
Here we go. That girl. Yeah, did you say Tingle?
She said product
Oh,
rule.
never mind. Never mind.
Alright, so
They were embarrassing.
I'm not.
derivative of the first times the second plus the first times the derivative of the second. Now I want to evaluate m prime of 2. So if I plug 2 in, I will have g prime of negative 4, right? Just multiplying that by 2, times 2 times h of 2 plus g of negative 4 times h prime of 2. So now, I just want to pick out all of these values from both the table and the graph. Right? I've got a table to define g and a graph to define h. So, g prime of negative 4 is negative 1 times 2 times h of 2. So if I go to my graph, wait a minute, that's not on a nice coordinate point. How would I find that actual value there? Well, h prime of 2 would be the slope. H of 2, we would use the slope to find. Yeah, so if we know the slope is negative 1/3, right? So this point would be 1, negative 1/3. This would be 2, negative 2/3, 3, negative 3/3. Right? So this coordinate point is just negative 2/3. Then g of negative 4 is 5. And h prime of 2, we already found, was negative 1/3. That's it. Stop there. Don't do arithmetic. What's that?
I can't help it.
No.
Nobody can. Yeah.
What?
I thought it was that here.
I don't know.
I have a serious question. What does this mean? For you guys. Oh.
All right.
Yeah.
Part D then says, is there a number C in the closed interval -5 to -3 such that g prime of C has to equal -4? So, on the interval, if we're looking at g from -5 to -3, it's asking me a question about the slope, right? G prime. So on the interval -5 to -3, I want to find the average rate of change, or the slope between those 2 points. So that would be 10 minus 2 over -5 minus -3. So 8 over -2, which would be -4. You okay? So the question says, is there a number c such that g prime of c has to be -4? Well, if the slope between the endpoints is -4, there has to be some value in between the endpoints where the instantaneous slope is -4. MVT. That is the mean value theorem. Mean, or average, right, is average rate of change. So mean value theorem talks about the slope.
Would it have had to be -4 to pick any other answer?
Exactly. Yes, it would have to be -4. Mean value theorem says if the function is continuous and differentiable, then we are guaranteed that the average rate of change has to equal the instantaneous rate of change somewhere on our interval.
So how do we say?
Well,
Is that
we would need to say, since the function is continuous and differentiable, then the mean value theorem applies, right? We have to say the first part. We have to use the stem of the hypothesis of the mean value theorem. It's continuous and differentiable. Therefore, since the average rate of change is -4, we are guaranteed that somewhere the instantaneous rate of change is -4. All right. Questions on this one? All right, so you have the scoring rubric on your paper. You can see how the points were divvied up. 2 points for part A, 2 points for part B, 3 points for part C, and then 2 points for part D. All right, so the next one, okay, is given a table. This one we want to find some different information. On this one, the table shows the height of a tree. And for part A, we want to estimate h prime of 6. How would I do that?
you take this slope?
Okay. We just want the slope between these 2 points. So 6 minus 11 over 5 minus 7. So -5 over -2. Now, what would the units be for this? So h is just meters, right? So the derivative of that would be meters per year. All right, so B, explain why there must be at least one time between 2 and 10 such that h prime of 2, or h prime of t equals 2. All right, so they're telling you this is true. Figure out why. This is another mean value theorem question, right? So we want to look at slope. Well, if I look at the slope between my endpoints, between 2 and 10, I would have, what, 15 over 1.5, or 15 minus 1.5 be 13.5 over 8. 13.5 over 8 is definitely not 2. Hello?
I'm sorry, I'm broke.
You can keep it down there. I'll run down and get it after this period. Thanks.
I'm upset.
I knew
Why are you
it.
awesome? Dude, don't
Maybe
tell
it was
me
graduation. Maybe it was the brag because she got money
You
in her
just-
job now, but always
It
complains
was
about the
literally
stupid job.
See, Olivia, she just complained to me about $10 shipping and said I better love it because it was $10 shipping. Tell me that's not guilty.
But Mia just complained that she worked 32 weeks, so then
Yeah, 32 hours.
that's what I meant.
32 hours.
32 points.
Alright, you know what?
All right. Back to
I'm
calculus.
just kidding, that wasn't for you, that was for them.
You definitely went around.
Yeah,
the
you
whole
brought it all the way around.
Sorry.
Alright, so we know that part B has to deal with the mean value theorem. But if I look at my endpoints between 2 and 10, I definitely do not get a slope of 2. So all I'm trying to do is find 2 points where the slope between them is 2. Okay? They're telling me this is true. Figure out why. Well, if I start trying points, I end up finding that between these 2 coordinate points, okay, between 3 and 5, I would get a slope of 2. Okay, so if the question is worded like this, explain why there must be, they're telling you it's true. Figure out why. So we would want to say, well, if I look at t equals 3 and t equals 5, the average rate of change between those is 2. Therefore, by the mean value theorem, I am guaranteed that h prime of t equals 2 somewhere in between t equals 3 and t equals 5. Alright? Okay with that one? Alright, yeah. Give you a second to write that down. So then C deals with a trapezoidal sum. Yes. Just trying to get through as much as I can. So trapezoidal sum with 4 subintervals. Okay, so my first trapezoid is just between 2 and 3, and then these are my heights. Right? So I'm saying my first trapezoid has a height of 1, and then my bases are 1.5 and 2. Then my second trapezoid would have a height of 2, the difference between 3 and 5, and then its heights are 2 and 6. Then my next trapezoid would have a height of 2, and my heights are 6 and 11. My final trapezoid would have a height of 3, and its bases are 11 and 15. We're done. Don't do the arithmetic. Don't do it. Okay, that would be the answer to the trapezoidal sum. We do need to have the area formula for a trapezoid memorized. And if you can't do that from the table, you can sketch it out, right? Sketch out the situation and say, well, my first trapezoid is going to go between 2 and 3, and then has a height of 1.5 and a height of 2, right? It's okay to draw it out, and then find the area from there. Right? If you need to draw it out, that's perfectly fine. Right? Part D then says, well, we can actually model the height of the tree by this function. 100x over 1 plus x, where x is the diameter of the base of the tree. When the tree is 50 meters tall, the diameter of the base of the tree is increasing at a rate of 3/100ths of a meter per year. According to this model, what is the rate of change of the height of the tree with respect to time when the tree is 50 meters tall? Whenever we see something like this, rate of change with respect to time, this is a related rates problem. Okay? This has been generally how they throw related rates on the test in recent years. There have not been entire questions dealing with related rates. They just throw it in as a small part of a free response question. Okay, so what we know, okay, we know that the tree is 50 meters tall. We know, so we're saying that G is the height of the tree. So we can say that at this moment in time, G is equal to 50. I know that X is the diameter. So the diameter of the tree is increasing at a rate of 3/100ths per year. So that would be dx dt equals 0.03. Let's see, what else do we know? So we want to find the rate of change of the height of the tree. So the rate of change of the height would be dg dt. That's what we want to find. Now, let's see, what else do we know? I guess that's all we're given at this moment. Right? So how would I find my rate? Derivative. A rate is a derivative. Okay? So what we want to find here is the derivative of this function. So dg dt will be equal to, I have to use quotient rule here, right? So that'll be 1 plus x squared. Bring that 1 plus x straight up times the derivative of the top, which should be 100, minus the derivative of the denominator, which would be 1, times 100x. And I actually forgot something, didn't I? When we take the derivative of x, mess that up. We need a dx dt, since we're differentiating with respect to time. So this would be 100 dx dt minus the derivative here would be dx dt times 100x. There we go. That looks better. Glad you agree. Well, no. So we need to solve for dg dt, right? Now, whenever g equals 50, we can use this equation to figure out what x is. Right? So if I say 50 equals 100x over 1 plus x, well, I can multiply my 1 plus x over. So I would have 50 plus 50x equals 100x. Subtract the 50x over. Divide by 50. We get that x is equal to 1 at this moment. Right, and then we know that dx dt is 0.03. So I can just plug 1 in for x and 0.03 in for dx dt. So dg dt whenever x equals 1 would be 1 plus 1 times 100 times 0.03 minus 0.03 times 100 times 1 all over 1 plus 1 squared. And we're done. Don't do the arithmetic. Okay? And they even tell us the units. Right? It even tells us that our units would be meters per year. So we can tack on meters per year here. we okay with something like that? Now, something that may not have been immediately obvious would be to solve for x, right? But if you look at the scoring rubric on the next page, 2 of the points were just for taking the derivative, right? So even if you don't know where the information comes from, what each piece should be equal to, 2 of the 3 points you get just from doing this much, just from using quotient rule and taking the derivative. Okay, so even if you're not sure how to finish a problem, try something. Okay, start it. This is all about just accumulating as many points as possible, not necessarily getting all of the right answers. Okay? So we've got 10 minutes to talk about the next type. But this one is one that we've done a lot of recently, okay, differential equations. So the bulk of a differential equations problem is solving the differential equation. Okay? Generally, part A is either sketch a slope field, or it could be to sketch a solution curve for a slope field. And this is worth 1 or 2 points. So we've done a little more practice with sketching slope fields, so I wanted to take a look at one where we had to sketch solution curves. Okay? And all this is just kind of following the slope field. So here we want to sketch 2 curves. The first that passes through the point 0, 2. So the point 0, 2 is right here. So if I follow the slope field out in either direction from that point, well, that ends up just being a horizontal line, right? So there's my first solution curve. The second one, I want to sketch the curve that goes through the point 1, 0. So if I follow my slope field, get something that looks like this. So all we're doing is kind of connecting the dots, right? Connecting the slope fields, just drawing lines that follow these slopes. Part B on this one says, let f be the particular solution with initial condition f of 1 equals 0. Write an equation for the tangent line and then use that tangent line to approximate f of 0.7. So I need 2 things to write the equation of a tangent line, a point, and a slope. I already have my entire point, right? 1, 0. So the only other thing I need is the slope at that coordinate point. So, zoom out a little bit here. I'm given the equation up here, right? 1/3 x times y minus 2 squared. So all I'm doing is plugging in the point 1, 0. So I'm plugging 1 in for x, so 1/3 times 1, and then 0 in for y. Oops. Minus 2. So we get 1/3 times 1 times negative 2 squared. So that would be 2 squared is 4. 4/3. So I've got all the information I need now. The slope is 4/3 at the point 1, 0. So 0 m equals 4/3. Write the equation of the line. So y minus 0 equals 4/3 times x minus 1. Now the bulk of the points on a problem like this comes from the final part, okay, actually solving the differential equation. So, to solve a differential equation, okay, with the initial condition f of 1 equals 0, the first thing I need to do is separate the variables. Get the x's and the dx's on one side, the y's and the dy's on the other side. So to do that, I'm going to divide both sides by y minus 2 squared and then multiply the dx over. So I end up with dy over y minus 2 squared equals 1/3 x dx. Now, I'm going to rewrite this as y minus 2 to the negative second power dy equals 1/3 x dx. Then I can take the antiderivative of both sides. How would I take the antiderivative of y minus 2 to the negative second power? Yes, it would. Alright, are we comfortable doing something like that? How about 1/3 x? So we know we're going to add 1 to the exponent, right? So we know we'll have an x squared. What about the coefficient? That'll be 2/3. So if I put 2/3 there and I take the derivative, I would multiply and get 4/3. I want it to be 1/3. We would divide. So 1/3 divided by 2 would be 1/6. Plus c. Don't forget your plus c. On these types of problems, if you forget your plus c, you're automatically losing at least 3 points. Because the rest of the problem is solving for c. Right? We need to plug in our initial condition and solve for c now. So I'm going to plug in 1 for x, 0 for y. Solve. So this is, let's see, negative 2 to the negative first. So how would I do that? What does that mean? Yeah, this would be 1/2. So then I subtract the 1/6 over. And if you're not comfortable with adding or subtracting fractions, you could just say that this is equal to 1/2 minus 1/6. You don't have to do the arithmetic. Okay. So if we did do the arithmetic, though, this would be 1/3. 1/2 would be 3/6 minus 1/6 would be 2/6, which would be 1/3. So then the final part is to plug that 1/3 back in for c and solve for y.
I can't. It says throw the app as a person who can't do crap.
So if we plug this in now, 6x squared plus 1/3. So now I just need to solve this for y. Okay, so this would be the same as negative 1 over y minus 2. So the easiest way to do this would probably be multiply the y minus 2 up, divide everything by 1/6 x squared plus 1/3, and then add 2.
So you're gonna have to do 2 practice here.
So yes, just the 2 practice problems for homework.